Aye, so this is the fourth video now, fourth video. So quick recap of what we've been going through. As you can see there, I've changed pen styles. That was an exciting moment in the video series. But yeah, we've gone through basic differentiation. So just how to turn our functions from the index form to the differentiated form and back to third form. That. And then we were looking at a little bit of complete the square and describing why functions are increasing or decreasing. We looked at the stationary points, getting those coordinates, and then probably the most complicated one so far was working out our the maximum and minimum y values given an interval. So we have to work out our y values at the interval, and then we have to work out the y value at any turning points and give us the nature of that turning point as well. So it's not overly complicated, but you can see the question does take a bit of time. You've got to differentiate what's the value of your turning point, what's the y value of your turning point, what's the nature of your turning point, what's the y value for the extents, and then compare them. So I think when you see the answers, you think, yeah, okay, I can do that. The only thing is now and again they throw you a little curveball, like for the factorizing, which can sometimes be a bit tricky. So you might have looked at this and went, oh, how to factorize that? I'm not sure. So trying to think on the process is very important, but also just practice as many as you can so that little curveballs don't don't drop any marks. Okay. The next one, this is a really good skill here. They love this kind of question. If it's not stationary points, they are looking at the equation of tangents to curves. Okay, so we'll do these two in this video. So when you're thinking about this, you should be thinking to yourself, okay, I have got my x and y axis. I'm sure there'll be someone watching this wondering why I don't use a ruler. It's because I'm lazy and because I'm rubbish at finding the button. But yeah, see, I've got a graph, something like this. And the question said, find the equation of the tangent to the curve at x is -2. Well, our tangent would be going along, I don't know, maybe that's x is -2, there. Our tangent's doing something like this. Okay. So to get any equation of a line, you need a point, you need a gradient, and you need the equation. That should always be in your head. Okay, so y take away b, mx minus a. Yeah. Always be in your head. And you should be thinking, okay, well, how am I going to possibly get the point? I only know x. Well, let's just substitute that in, won't we? So we know x is equal to -2. So let's substitute, let's say, well, y is equal to 2 times -2 cubed plus 3. So that's going to give me -8 times by 2 would be -16 plus 3 for -13. So I know my point there, y is equal to -13. That looks like a positive, sorry. So my point is -2, -13. Excellent. Gradient, usually we need 2 points to get a gradient. I don't have my 2 points, but what I do have is my equation, and I know if I differentiate something, that is going to tell me the gradient. Dy by dx is the rate of change, which is the way of saying the gradient. So 6x squared, the gradient, I want to know the gradient when x is -2. -2 squared is 4 times by 6 is going to give me a gradient of 24. Now I'm ready to substitute in here. So it's going to be y, take away b, so it's going to become positive. 24x, that's going to become a positive as well. Break the bracket out. I'm going to get y is equal to 24x plus 48. And don't forget my 30, sorry, so 24x, 48, and then I'm going to take away the 13 as well. So y 24x plus 35. Fantastic. Looks like a b I've taken away at the end there. That's a 13. I've moved that over to that side. So actually a really good 4 marker. Point gradient equation. Get your point by substituting into the original equation. Get your gradient by differentiating and using your x value. And then it's your standard equation of a line. Let's try the next one. Find the equation. Point is 2. The tangent equation. So I'll start with PGE. I do like these ones because the working's not too long, and it's a nice blend of using your skills and without lots and lots of crazy working. So it's more skill based than length and complexity. Now the x is 2, so y is equal to 2 to the 4. Take away 2 cubed plus 5. So 2 to the 4, what's that? 2 times 2 is 4, 8, 16. Take away 2 times 8, which take away 16, plus the 5. So y is going to give me 0. No, why is it going to be 5 to 16? Oh, okay. 62 to 60, that's going to be 5, obviously. So I've got 2 to the 5, that's my point. The gradient would be, let's see, dy by dx is going to be 4x cubed. Take away 6x squared. Let's substitute 2 into that. So 8 sin 24, that'll be 32. Take away 24. That'll give me a gradient of 8. Excellent. And we'll just do the last bit again. Still loads of time. So it's quite a quick little run this video. Y take away b, mx minus a. Just watch obviously what I was saying there. I was saying that was 0 for some reason. Obviously, take your time. Too busy yapping. Y take away 5. Then break that bracket. So that's 8x take away 16. Add 5 to both sides. So y is equal to 8x take away 11. You've actually left it seeing the answer there. I think you're better off if you can getting down to where I've got to. I think I would only leave it in that kind of form. I would never leave it in that form, but I would leave it kind of like this if I multiplied through by a fraction or something. Take away 11. Fantastic. So, for me, probably the easiest video section so far. But the skill you need to know here is that the gradient is your differential. So you're differentiating and substituting that value in. And it's using your straight line skills as well. So actually, it's all things you've learned this. Well, I suppose there's a wee bit of National 5 in there, but it's things you've learned this year with your equation of the line and then thrown in that as well. So that's us done, I would say, a lot of the standard work for differentiation. The next series is going to be on optimization, which is where things get a bit tougher. Hope you enjoyed that.